This is the Amp Hour podcast, released July 31st, 2023, episode number 641 with Toby Robb. Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And my name's Toby Robb, and I've been working in distribution power industry for around 14 years.
Hey, Toby. Thanks for
How are
joining
you,
us,
Dave?
mate. Good.
Welcome,
Good
mate.
to have a fellow Aussie on the Amp Hour again.
Yeah, I'm not too far south of you, I think.
No. Where from exactly?
I'm just south of Wollongong there in the Illawarra.
So yes, power, something both Chris and I don't know. Well, power distribution and big power stuff, something Chris and I don't know about. We've had Paul Zawada on the show before. He talked about the smart grid and all that sort of stuff, so I'll link it in. But you're more into like the transmission line stuff. So tell us what your day, what's a typical day for you?
Well, so I suppose in the last few years, I've actually been sort of stuck behind a desk a bit more. But I'll probably try and talk about, the sort of 10, 13 years before that. I started with my company as an adult apprentice and basically became a linesman and what we call a fitter over here. It's basically just an electrician. But yeah, I work on the distribution network, which is basically poles and wires. So all those poles and all those wires that are out front of your house, or maybe you've got some underground where you are, but I work on all
We're
that.
completely underground. I was going to ask about
Okay.
the difference between underground and poles, but we'll go into that later, I think.
Sure.
Let's not just jump directly into that. Tell us, where does power come from, and how the hell does it get to us, and what are the perils and pitfalls and stuff that we all take for granted because most of us just design stuff that plugs into the power point
That's right.
or powered
That's
from batteries,
right. Look, it's been around a very long time, the industry, and it's sort of a little hidden industry. It sort of runs in the background, and you don't really know about it until something's wrong.
Yeah.
But in Australia, we have our distribution network providers who sort of run the poles and wires business, and then you've got all your generators, and you've got your transmission. And so, in Australia, we've got probably three or four, big generators in New South Wales, and they push out all our power. They push out around 600 or 700 megawatts a second. And
Well, are you talking about the actual generators or the generating
so-
companies or the generation companies?
There's sort of unusual ownership arrangements on a lot of them, but there's, to provide the power for the whole state, we've got to have a couple of generators, and we've got some big ones that are all coal-fired, steam-powered prime movers, and then there's a few little ones. There's some solar installations, some wind installations all around the place, but all combined, they all get their power and they push it out onto the transmission network, and that's a separate group. But the generators, there's a few in the north of the state, few in the south. They're scattered around, and they all send their power to marshalling stations or marshalling yards. And these big distribution centres, there's one, I think, just near St Mary's there, they all send their power directly to that distribution centre. And then from there, it's sent out via transmission networks. And that's when it gets to the likes of Ausgrid, Endeavour Energy, Essential Energy, those three main providers for the state. And from there, off they go on their little 132 kV towers and head out to all the zone
Little,
sites.
132k is little. Not to me.
It's funny, Dave, we use the term low voltage for LV up to about 1,000 volts, so we consider that low voltage.
Right.
And then we have our high voltage.
I think in the realm of electronics, it's officially 40 volts or 42 volts or something, isn't it? Something like that is considered low
Probably,
voltage in the electronics.
touch safe, I think, maybe 50, 60 volts DC.
Yeah, something like that.
Something like that.
Yep.
Yeah. It's quite a big industry, and there's actually a lot that goes on. There's quite a bit of engineering that goes into all of it. Not only all the work that gets carried out in the street, all the poles and the wires that have all got to be put in, maintained, and looked after, but there's a lot of engineers that run in the background too to design all the protection systems. for the transmission the zone subs. So I don't know where the best place to start is, but
Generation?
yeah, the prime movers, they're mostly coal driven, coal fed. The coal comes in usually on conveyor belts from a nearby coal mine, or they have a big gathering area where they just pile up the coal, and there's a big like a feeder that grabs it and crushes it, powders it, and then throws it into the furnace. There's usually near every generator, there's usually a water source, and that water's brought in, and they make steam, and they drive a turbine, and they call that the prime mover. It usually pushes out around 12 kV on the rotor, and they then put that into their local marshalling yard and bump it up to usually in the 330 to 500 kV range, and then they send it out to the various areas for splitting up.
Why does the generator only output 12 kV? Is that just like the wind in like breaks down
Yeah,
and stuff
so
like that in the
yeah,
motors in the
correct.
gens?
So sort of high voltage machines, they're sort of hard to insulate at the best of times. And so
Yeah.
when you've got this big spinning generator that everyone has to work on, and they as long as 3 or 4 buses, some of these things, they take up a big whole floor. And yeah, they sort of limit the output. And then but of course for transmission we want that high voltage to have that low I squared R loss, so they push it up to the 330/500.
And they
Yeah.
do that straight away because you don't
Yeah,
want to be
straight away.
transmitting huge power
That's
from the
right.
main generator any sort of distance. You want to bump it up to 500 kV as fast as you can, or as near to the gen as you can.
Yeah, and they'll bump it up straight away and then send it out from there, and that's when Transgrid get a hold of it, and they'll send it out throughout the state, and they'll manage that sort of higher level generators coming on and offload and picking up the load, because the generators, they do have a governor that holds the generator at 50 hertz. So as the power load increases, the throttle will open up and she'll put a bit more power in to keep that 50 hertz going.
But on average, over a long time, it's almost precisely 50 hertz.
It
Is that
really
right?
is, yeah,
Yeah,
yeah, it's
it's pretty
very
bang
good.
on.
Yeah, it's actually kind of fascinating the way the synchronicity works across the network. That the generator is spinning at 50 hertz, and it's pushing and pulling that electric field right out through the neighborhoods. And there's three-phase motors in premises and industrial processes that are all spinning at the same speed, and it's like the big generator sort of divvied up its work, and it's all in all these other smaller machines, but they're all still running as well.
How do the different generator plants synchronize together? Is that done via like some,
Oh, good
comms like
question.
optical fiber network, or do they? Well, I guess this
Oh,
isn't precisely your area, but or can they just like one of them is like the master and the others are kind of like slave, and they just
they're
know?
all
I don't
synchronized,
know.
Dave. One of them could drop on and off, and it
It
wouldn't change
wouldn't
the
matter,
others in
right?
any way.
Okay.
Yeah.
Yep. Got it.
I guess that's why the black start would be a problem where you don't have a synchronized source,
You've got
and
nothing. The
yeah,
grid,
you've
the
got nothing.
entire country's grid is completely down, and you've got to bring it up from scratch.
Yeah, and that's why there's things like the hydroelectric system, which can just instantly push out about 20 or 30 megawatts straight away, and that's enough to supply the rotors in the big prime movers with some current
Ah,
to
got it.
then
So if you had
induce
no
something in the field
hydro,
coils, and off they go. Yeah,
so how
yeah,
would you,
that's
if you
right.
had none of that instant hydro energy, how would you start up the
Yeah,
big
I'm not
gens from like
sure.
nothing?
I'm not sure. They could have. I mean, it'd be pretty unlikely to have, all of the generators stop working.
Yep.
The protection systems isolate all that stuff straight away, so that it's unlikely that they would stop completely. I'm sure
What
they've
is the
got a
biggest
plan for it.
outage we've had here in
Ooh,
this state, New South Wales? Because to me, I've lived here my entire life, right? So
yep,
it's always been almost 100% reliable. I can count the
yeah.
number of blackouts like on two hands, like and like they don't really last longer than like a couple of hours at absolute
Yeah, no, it
most.
is really good. Obviously, everyone gets their outages when there's program work. You get your
Oh
notification,
yeah, of
they knock the
course.
power
Yep.
out for a day. But, unplanned outages, there's a fair few in the regional areas, under storm or bushfire conditions. They're the ones that
Yeah,
seem
right.
to cause the most outages. But and then sometimes you get the cable interconnects. Like I don't know if you remember that. I think there was one that was across the harbour there. One of the primary cables failed. The secondary cable picked up the load, but it just couldn't handle, and then it
Ah,
failed.
no,
I
I
think that
don't.
was
I don't
in
remember
Sydney
that.
somewhere. But that was,
Right.
and that was about a half a day or a day or two. But yeah, we're pretty fortunate here. We don't have long-term rolling blackouts.
Yeah, I mean, of course, we had the famous one in South Australia that actually
Yeah,
resulted in that was bushfire related, wasn't it? The poles just
I think so.
totally
Yeah,
collapsed or
or
something,
storm
and then
related.
the
Yeah.
yeah, or something like that. Yeah, there was a huge, and that took down like you know a whole grid. In fact, the control center for all of the eastern seaboard is here, just a stone's throw from my lab. And the bastards wouldn't let me in.
Yeah.
Apparently, this is
Yeah.
where they control it all from. They don't just control
E-
this state. Apparently, they control the whole eastern
Okay.
seaboard. Is that?
I'm
That's
not
what they
sure.
told me
I know
anyway.
that literally every company has their own control rooms. I can only speak. The company I work for has sort of a north and a south control room, and they monitor all their incomings and outgoings, and they can switch pretty much anywhere on the network and switch around any sort of problems. And yeah, they do have to. I think they have to look at what the potential demand's going to be. Like they sort of start to get really concerned on the really hot days. They make sure they've got a plan and they've bought enough power for the day. But other than that, it's fairly simplistic, and each of them all coordinate. But when there's outages that go between uh, companies or between systems, that's when they have to do a bit more coordination, because you might have to ask someone at the other end to do some switching for you.
Do we get power from other states, or are we a net exporter? Do you know?
Dave, I don't know. I'm not going to say I'm a basic liney, but I,
Right,
there's a bit of a thing in the power industry about linies and fitters. Who's the best?
right.
But
Got it.
you know what I mean. But out west, you'll
Yep,
find they're
yep.
pretty much identical roles. But in the city, you got your linies and your fitters. But
Right,
from a distribution network point of view, we don't see a lot of that. Um,
right.
and because we haven't had many outages, we've never really even had to sort of deal with it, I guess. But
Got it. So what is the highest voltage that you deal with
so
as a linesman?
yeah, so 132 kV is the highest network voltage for our towers, and that will be the same for people like Ausgrid, Endeavour Energy, and Essential. They're the New South Wales providers, and we'll get the power at 132 kV, and that comes from Transgrid, their marshalling yards, and from there they'll bring it into the zone subs. You probably see they're sort of almost look like city buildings with a
Yep.
um, almost like a dwelling, but a bit more industrial. And then they've got the gates and the big
Yep.
fences around
Yep.
them.
Seen
Yeah,
them.
and they'll have some outdoor transformers. Sometimes they'll have indoor transformers. They're like they put walls around them, but they're open to the sky. And they'll buck the
Okay.
132 down to 66 or 33.
What are those? Are those walls just like fire containment, so it doesn't
Yeah,
spread to
fire.
the rest of the facility?
Yeah, although, touch wood, we haven't really had many of those. But yeah, things like that. Just also maybe visual amenity as well, because they have to be in neighbourhoods.
Oh,
All of
okay.
them are
Right.
bunded as well to catch any spills if there's anything like that was to happen. So they're all pretty well maintained like that. Um, but they're what we call our transmission zone subs, and they don't really have any customers connected to them. They just take that 132 and then they split it up to send to our other zone subs, which are the ones that are a little bit closer to town potentially.
I got it. Okay, so we're still talking outside of outside of Sydney here, are we?
No, there's transmission subs. There's one in Blacktown. There's Parramatta. There's transmission subs all around the place. Hoxton Park, but they're sort of one of those might do several suburbs or more. Provide those 66 kV transmission lines, and that's when we sort of lose the towers. And now we're going on
Okay.
to our
Yeah.
poles.
Right. So we're talking. So transmission is usually 330 or 500. Right.
Yep.
Main transmission from the power stations, and then
Yes,
then 132 is the next level,
that's right.
and
Yep.
then 60. What is it?
66.
66 is the next
Yeah.
level after that.
Yeah.
Okay. Got it.
And and that's when we get onto the poles. Often it'll be maybe a vertically constructed concrete pole, or maybe timber poles. And one of the tricks with insulators, if you count the number of rings, you can kind of get a rough idea of the voltage. Maybe there's six skirts on the insulator. You're looking at 66 kV. You might see 3 skirts. It might be 33. So from there, that's when we get to the zone subs, and there'll be one of those per suburb. There'll be one in
Right.
Penrith, there'll
Got it.
be one in
Yep.
Blacktown, there'll be one for every suburb. They're quite smaller, and that's when we take the 66, and there might be a couple of transformers hooked up to a bar, and then from there they'll have an output of around 11 kV, and that'll connect to a bar, and hanging off that bar will be a number of breakers, 11 kV breakers, distribution breakers, and they're the ones that then go out into the streets on the poles again, and they're the ones that power up the transformers that are on the poles, or the pad mount transformers that then produce our low voltage.
Which is 240 volt three. Well, the
230
three
volts,
phase.
230
Sorry,
volts
yes.
and
Oh,
400.
I'm old school. Sorry, that they changed that in
So
like the 1980s, didn't they?
it's a bit silly. It's I think we're trying to align with the rest of the world, so it's plus 10%, minus 6, so
Yep.
253 to 217, I think,
Yeah.
something around there. The point of it is that some people are bringing their 220 volts up to 230. We're bringing our 240 down to 230. Half of that, the 115s. Some of the 110 countries are coming up to 115, and so on.
Okay.
So
Right.
I think there's some alignment there. They're just obviously it makes sense to minimise the number of voltages in equipment around the world.
Yeah, of course. Who makes who makes the transformers? Is there
Oh,
like one
lots of them,
company that specializes? No, there's lots. Okay.
lots. So our friend Chris, ABB, I believe they make
Oh
quite a number
yes,
of
yeah. Used to
really
work at
good. They
ABB.
make
Right.
lots of gear. They make a lot of switch gear and transformers. But they've been over the years. There's been various manufacturers, contribute. Some of the transformers, like a 132 to 66 kV, you might need a 1 year lead time to get something like that,
Oh, okay. Wow.
potentially, and you may
Yeah.
need to get it shipped on a truck that will block 3 or 4 roads, 3 or 4
I've got a video of one
things
of those.
wide. Okay.
I actually haven't uploaded it yet. I'll put it on my second channel. I was just going in there. I was just driving through the outback, and we had to pull off to the side of the road. The cops
Wow.
came past,
Yeah.
waving everyone off. Here comes this huge truck with this massive ass transformer
Yeah.
hanging over the sides of the truck. So they had to
Yeah.
shut down the whole highway.
Yeah.
Just
And
yeah.
a lot of those zone subs will have anything from sort of 1 to 4 or 5 or 6 transformers potentially. Do you want to talk a bit about the arrangement of the transformers and the way they are connected?
Yeah, we can
Kind of
definitely do that.
interesting.
I've just got one question
Okay,
about,
sure.
before I forget, about the industrial business parks like I'm in.
Yeah, yep.
Are they treated any differently power wise to like a regular
Yeah,
suburban
a
suburb? I
little
assume they'd
actually.
use more.
Yeah, they do. And so a lot of them, they're what we call HVCs, high voltage customers, and some of them will take the power straight from the company at 11 kV, and they'll have their own transformers.
Yeah, because my building, my building here has like a massive room that powers this
Okay, yep.
entire building,
Y-
and I assume that's 11 kV input, is
Yeah,
it?
you'll see
Right.
them. They'll have warning
Yep.
electricity, and there'll be a locked
Yeah.
door, maybe
Yeah.
vented and things like that. And yeah, they'll have an indoor transformer that's at ground level,
Yep.
so a little bit tricky to work with and manage, because it's right there at ground level.
Right. Oh, maybe you're the guy to give us a guided tour of a room like that. Would
You
that be
know,
your area?
I would love to
Or
to somehow get you a tour of one of our nice new zone subs. I might have to
no,
try and ask
I'm
around for
talking
you, but I
about
can't.
my
Oh,
building
okay.
here. I'm talking about my building because I
You
can
know,
get access to the room. So,
you need to wait for someone that's. You probably won't get access to the transformer room. It definitely
right.
will be
Okay.
keyed. Yeah, but like you say, they do. They have a transformer room. Sometimes they might have a couple of the green pad mount boxes just out the front, and they'll
Yeah.
have,
Yeah. I've seen that.
low
Yep.
voltage cable, quite heavy duty cable running into the building, and they'll have their own switch gear in there and their own protection distribution boards. But yeah, a lot of them do. They have an indoor transformer. Yep.
Right, interesting. So how like do you have problems with like the government say, "Oh, we're building a new suburb, boom, right here and we want to get it done." You guys go,
Yeah. Well,
sorry, we don't have the spare power available."
no,
Is that a thing?
they can
Because I know
spin it
that
up
happens with
pretty quick.
sewage. I know that happens with like sewage and water and
Yeah.
stuff. It's like the government says, "We're going to install a new suburb," and then the authorities go, "No, sorry, we don't have the excess
Yeah, no one
capacity on
likes to
the."
get told second. But
Right.
they generally have to apply. I think for a certain size of connected load, you must advise the distribution provider that you intend to do it, and they'll take a look at the infrastructure that they have in the area, and then there's a little conversation around how it's going to be provided. Below a certain amount, though, your average person with a house, not really something you have to talk to them about. They've got that capacity, but yeah,
No, of course,
over a
but an
certain
entire
load.
suburb, if the government
Yeah, oh,
says, well, we're
yeah,
going
for
to plonk a
sure.
new
Yeah.
suburb here, like a suburb
There's
takes a
been a
lot,
lot
right?
of building lately around the
Yeah.
airport sites and everywhere else, and yeah, it is. It's planned well in advance.
Now, getting back to, sorry, we've got sidetracked. What were you going to talk about?
Oh, just the way the transformers are hooked up is it's really interesting. The inputs generally come in and the outputs they generally come into what's called a bar. It's just basically a bar, a metal bar.
Okay, it's
Um,
physically a bus bar.
yeah,
It's
bus bar,
physically a
but
giant,
really big.
is it copper? Is it
It's
copper bus bar? Or
aluminium
is
mostly. Most of the
aluminium? I was going to
materials we
say.
use are aluminium because it's lighter and it's
Yes.
almost as conductive. It's
Yes, as
very, very
people
close.
don't know this, power lines. Please correct me if I'm wrong, but practically every power line, every street pole, every 500 kV transmission
Yep.
line, it is not copper.
It is not copper. There are some older areas around Blacktown, a place like that. You'll notice they'll
No,
have a green
right,
tinge
okay.
that are copper, but they're
Oh,
pretty
okay,
rare. You
interesting.
might see a
Right.
streetlight conductor, which is a
Yep.
separate conductor underneath, and that's often copper, but it's extremely heavy. I think the density is maybe 8 or 12 or something, and aluminium's in the two.
Aluminium. Even though it's
Yeah.
not as good a conductor, you're willing to trade off
It's
that for
very
the
close,
weight.
and you
Right.
can up the size of the conductor slightly.
Right. Yes. Got it to compensate, and it's still lighter than the copper
It
equivalent.
is, and
Yeah.
the spans and the length of the spans that you must do I mean, we've got spans that can go up to 700 meters.
Oh,
The,
wow.
the stuff you see
Jeez.
around in the burbs, the 80-meter stuff, that's tiny. There's stuff that can go kilometer. Yeah,
Wow. Wow,
and
that's a
and that
heck of a
it
that's a
is a
heck of a
long way.
droop on the wire.
You should
Wow.
try being the linesman that's got to crank the tension up on it
I was
and
going to
wrap off
say
the
they would have
freeforms. Yeah,
tensioners, right? They've got to go up there and
yeah.
periodically
Yeah, they're like
tension
we
that.
call them luggalls. They're like a
Yeah.
ratchet strap on your car, but obviously they're engineered. You put a strap around the crossarm. You do what's called a come along. It's kind of like you've been abseiling, haven't you? There's a device I think that lets you climb and it only sort of
Yes,
goes one
you
way, but
can
not
ascend up. Yeah, yeah.
just one of them. It's just one of them. You put it on the wire, you push it out, it goes outwards fine. You hook it up to your lugall, and you start cranking it up, and it pulls the tension in,
So
and
do
then
they
you
have
tie it
to
off.
adjust those differently during the seasons? Because I imagine summer's going to get hotter, so
No,
it's going to
but
expand and droop more. Maybe is that a
it
thing?
does. They
Or
do sag. They do sag based on temperature, but all the calculations are done with the maximum sag and maximum current
got it? Okay, so you don't have to
in
adjust
mind.
it during the
No, not
year.
at
You
all.
just have to
No.
periodically
Yeah.
maintenance, kind
And
of.
all the
Right.
conductors, they're actually all quite different. Some of them are they're all multi-stranded, but some of them are an aluminium alloy. Some have a steel reinforcing core in the middle. You've got your covered conductors, you've got your insulated conductors, you've got bundled conductors, and they're all quite different, and they all have different roles. And if you start looking around the network, you'll start to identify some of the different ones. So, well, just back on the transformers, I guess, because that's
Yep.
that's where I suppose some of your engineering crowd might be kind of interested. Is that each of the transformers, they hook to bars, and the bars might have a breaker in between them to tie different sections of the bar together, and then each transformer itself will have a bar facing, say, the 130, a breaker facing the 132, and it'll have a breaker facing the 66 on the way out. Each of those breakers will have a VT, a voltage transformer, which takes a proportion of the voltage and takes it down to about 100 volts, so we can measure the voltage on the bar and coming
Okay.
in and out of the
Right.
transformer as a proportion. They'll also have a CT, a current transformer, and that'll measure a proportion. Might be a 200 to 5 ratio or an 800 to 5 ratio. And that'll measure a portion of the current.
How much
And
loss is there in one of those current shunts?
not a lot. They're not
Not a
current
lot.
shunts per
Okay.
se. They're when you get your multimeter that's got the
They're a current
clamp down.
transformer. Yes, they're a
Yeah,
current
so they just go
transformer, but they've
around
still got
a one wire
winding loss in
transformer, I
them.
guess you would
But
call it,
yeah, yeah.
one wire primary. But yeah, you just sample a portion of that, and that's how you sort of not only just look at the load going in and out of the transformer, but that's how all your protection works. So obviously you've got to protect on overcurrent, and you've got to protect loss of phases. You've got to look at the voltage and monitor everything. And so, all of those devices in the yard, and if you ever, look in a yard, you might start to recognize some of them. They'll all, sample the voltage and current, and that'll all come back to the SCADA control systems. And that's where things get crazy. There's, panels with relays in there that will measure everything and, trip the breaker accordingly. But the arrangement of everything's kind of interesting because back in the old days, your normal spinning meter that's inside your house, well, it's technically a motor. It does measure
Yes, I've
power.
actually done a teardown video on those.
Okay.
They're fascinating, absolutely fascinating. Yep.
Well, can you imagine getting one of those, but instead of hooking it up to a source, hooking it up to a CT, and so that, and imagine that it had a set of contacts on the disc, and when the and it's let's say it's receiving normal current, it sort of slips and doesn't move, but above a certain amount of current, it starts to make the disc move.
Oh, and they'd physically have contacts on that,
Yeah,
which
they
then it
actually,
detects
yep,
that and then cuts it off
yep, and
or
and
does
it
something.
works
Yeah.
well because
Right.
it follows the same inverse time constant. Really, the more current delivered to
Oh,
it, the faster it
yes.
turns. And so it may only turn a quarter or half a turn, but you can literally put pegs in the disc that will trip a set of contacts.
Wow. So it's a mechanical. It's effectively
Yeah,
a mechanical solution
but we've
for
gone
the
past
protection.
that now. But
Oh, okay. Right.
but they exist still. There's a few still out there. But the same sort of functionality's been replicated in software. Oh, not in software, but in hardware, electronics hardware. So they can all be programmed. But breakers, they're interesting too, because if you imagine an 11 kV distribution breaker feeding power outside onto the poles and wires has a fault or overcurrent, it will trip the breaker, and the breaker has a set of contacts that will tell you if the breaker's open or closed. If it doesn't trip, or the moment it goes to trip, the upstream breaker timer also starts, because if that breaker doesn't trip, that transformer will be in trouble. So the
Ah,
next
got
point of
it.
call is to turn the transformer off and trip it.
Oh, okay. So it talks upstream and goes, "Hey,
Yeah, and
I've got a problem. Be on standby. Be on ready timer for
yeah, so
if I
both
don't
timers
report
will
back to you."
start, and if the breaker doesn't open and those contacts don't show that the breaker opened, then the upstream breaker will trip.
Will trip just in case that
It will
yeah.
absolutely trip.
So
Yeah.
that's a fault prevention on top of a fault
Yeah, and
prevent.
that's
So
that's
if
why we
you
probably
right.
wouldn't have that runaway problem, because our protection's really good like that. Most of it's duplicated with standby relays as well, especially in the transmission zone subs. They're also battery backed up as well.
Right.
And the control
Interesting.
room
So,
knows what's going
yeah.
on as well.
Right. So what happens if ironically power fails to the control room? You have a
Battery
like to the
backup,
to the
DC
sub
battery.
right. So there is a DC battery in the
Yeah, they do. They
substation
have
that
AGM
powers
batteries
it.
there.
Right.
Yep, at all
Okay.
of them. Yep.
Right. I didn't think about that, but yeah. Ironically, what if the
Yeah,
power to the
and
power station fails?
yeah, the testing and commission and building of those is really fun job. Like, it's a really cool, interesting job because I don't know if you've seen them. They make these things called dobles. They're like a big power supply that's fully programmable and can put out, voltages up to 1,000 volts at whatever frequency and current you want. And then they have sort of logic inputs that can, you know, that you can see when they've triggered. So you might hook it up to a breaker. You might wrap the output around the CT a few times to double up or quadruple up the current, inject some current and see if the breaker trips. When the breaker trips and those contacts open, the dobe will tell you the time in milliseconds, and then you can check all your tripping curves. It's a lot of fun to build all that gear. And there's, like I said, CTs, VTs, and the breakers, and there's even standby equipment the breaker might be split in half. And so if a transformer fails and locks out, the bus tie breaker might close and bring in the standby transformer or put all the load onto one of the other transformers as well.
Okay, so every substation will have a standby transformer, will it?
Not every substation, but a lot of electrical equipment can handle overload a lot higher than its normal load. So maybe 150, 200% of its normal rated capacity
Okay,
it
that's
can
quite a
work with.
lot. But you wouldn't want to
Yeah, it
do that
is.
for like a week or something.
No.
You could do that for a day or half a day or something,
You
right?
might pull a transformer out of service to work on it. So you
Oh,
might
okay. Yeah, of
isolate and
course.
pull it out of service, yeah. And then of course you've lost that backup capacity, but it's usually, you know, been planned around. They'll have a plan.
Right. So what are the usual failure modes that cause a transformer like a substation trip?
Well,
What's the
they
usual fault
don't
down the line?
really the transformers don't really fail, but mostly
No,
it's
no, I'm talking about what causes the
yeah,
breaker to trip.
trees,
Trees on power
bushfires,
lines. So it's
storms.
shorted power lines, right? So
Yep.
it's
Yep.
shorted
So
and
phase to
open
ground,
power
phase to
line won't
phase.
because if people aren't aware, they most transmission lines in that you see like power poles and stuff, there are three phases. That's why they have the three wires on the top.
Yeah, so the high voltage network's three phase and it's three wires and they come into the transformer and they terminate in a delta configuration. So it's like a triangle. Imagine the wires attached to each point of the triangle. The sides of the triangle are one of the coils in the transformer. And then on the secondary side, you'll have four wires because it's in star.
Yes.
And
Oh,
what?
star and delta transforms. I
Yeah, that's
kind of
right.
remember those from.
And
I don't think I could do it today, but
one
like
of
straight off my head. But you know.
one of the questions I like to ask the apprentices is what are three phases add up to? Now you hear a lot of things, but do you want
Right.
to take a guess, Dave? What three phases add up to?
Three phases adds up
Three
to I don't know
phases. Yeah.
three phases. No, it's you're obviously a trick question, and I'm just going to
Kind of.
embarrass
Yeah,
myself. So
zero,
zero,
because
right?
that's where that neutral point, the center of that star, that's where it's
Yes, I've got
derived, and
right
that's at ground potential, and that's how we actually get our neutral.
now. Yeah, it's all flooding back. I totally remember. Yeah, we had that question in an exam one time. Yeah,
Yeah,
I
it's
totally remember that. Yeah,
oh the mathematics around phasor
yep.
calculations, it's not fun to do.
No,
Three phases
I
are
can
out of
kind of
phase by
remember
about
enjoying
120
it at the
degrees.
time, but
Yeah.
I can, but you know, it was like, man, how am I going to use this? Like,
Well,
I don't work
our
on three
power
phase stuff.
engineers do. They
Oh yeah,
look
of
at
course.
bolted faults, what we call a bolted fault, which is like basically as if the wires were bolted together, two phases. What's going to be the negative sequence current for that? Which way is the voltage going to go? How much current's going to flow? Because the amount of current flows depends on the impedance of the transformer. They have an impedance of around 7.5%. So that means 100 divided by 7.5, whatever that is if their normal current's 100 amps, it'll be 20 times 100 amps. It'll be their fault current.
Right, because I can imagine that's tricky. Imagine if your longest transmission line you can imagine as the short right at the end of the transmission line. You got all the other
Yeah,
loads on
you've
there.
got to
Would you
pick it up.
still be able to? How do
Yes,
you
yep.
pick that up?
We have two types of protection. There's lots of protection schemes. There really are, and they're individually tailored and designed for the kinds of equipment and that are present there, and the backups. Like I said, if there's a second transformer or not, a bus tie breaker mightn't be there. All those sorts of things. But yeah, we use an earth fault protection, and that's like a certain amount. So of course we got all the usuals: under voltage, over current protection. They're all there. But for a conductor, touching the ground or earthing or something like that, a fault like that, we use two types. We use a sensitive earth fault protection, and that's a lower current but for a longer period. And then we've got our earth protection, which might be 5 amps for 5 seconds would trip. But a sensitive earth fault might be as low as 1 amp, but it might need about 30 or 40 seconds to be seen for that length of time, and it says, right, there's something not right here.
Because you don't, it's a trade off, wouldn't it? It'd be a trade off between actually protecting your transformer and other infrastructure and allowing like
Nuisance trip,
nuisance tripping. Like
tripping.
I've had,
Yeah.
like I came back from holidays one time and all my fridges were filled with moldy growth because our the earth leakage circuit
Oh
breaker
no.
for
Yeah.
tripped. And
That
it just, yeah.
I think that's why you got
Whoops.
yourself that little power bank.
That little power,
Yeah,
but
great
yes,
idea.
the
Yeah,
battery bank
great
thing.
idea. I'm
Yeah, it's like,
thinking the
yeah.
same thing. Yeah.
Bloody annoying. Yeah, so it'd be
Yeah.
a trade off, right, between sort of nuisance things because
That's right.
your job
Yeah.
is ultimately to deliver power to a massive load of thousands of customers, right? Tens of thousands of customers while
Oh, it's a
protecting
million.
your equipment. Million, right?
Yeah, about a million plus customers.
Oh,
About
wow.
32,000 or so of those are on what we call a life support customer as well. Someone that needs electricity to keep their medicines cold, to help with
Hospitals
their
would
oxygen
be on a totally
concentrators.
different how would you wire up a hospital different? Would you give them a backup
They
transformer
have
and
their own
priority and have
feeder
their own?
usually. That feeder's marked in the zone sub so that we know that it is a hospital feeder. They also have a lot of their own generators as well.
Of course.
Um, yeah, there's a lot, 430 odd thousand power poles around.
Oh, oh,
It's a
what is
lot.
the difference between? I mentioned this at the start of the thing. Underground and poles, because my house and suburb is all
Yeah,
underground power, and I like that's a good thing for as far as the consumer's concerned, because you don't see these pesky power poles. There's less potential
yeah, yeah,
interruptions from trees and lightning and cars
yeah,
hitting them,
that's right.
and
Yeah.
all sorts of things. So, what is the difference? And do you guys have a preference for underground? Is it more
Well,
difficult to
all
work
new,
on? Is it
from what I understand, all new developments need to be underground. They need to demonstrate a reason why they can't be or shouldn't be. They might be a rural subdivision, but in general, they like them to be underground. I guess in a rural area, the aerial conductors, they're very easy to put back up in the air. They're very fast to restore supply. There's some associated, let's see, not difficulties, but when you switch with underground, it's inside cubicles. Um, it's a little different the way we do underground switching. You can't trace the conductors as easily. So, like to be a switcher on the network for underground is a slightly higher qualification in general. But underground, you're right. It's when there's a fault, it might be a little harder though because you might have to dig up everyone's the front driveways or whatever.
yeah, right.
Um, but
What
and
about for
but
faults like water ingress in the wires underground? Is that a
doesn't
problem
bother
or
them. Yeah, it doesn't bother them.
really?
It doesn't. No,
Okay,
not
doesn't
really.
right.
No, not at all. They also, believe it or not, the conductors actually are a little cooler in the ground. You can overrate a conductor when it's buried
Right.
slightly.
Okay. So you could potentially get away with a lower rating cable or more
Oh,
power
just
for a
just
given.
that they're just a little bit more secure down there as well, and they have a benefit of the cooler environment as well. And they're
Is there
not.
any extra loss in terms of like power factor and capacitance and all that sort of jazz? Is that
Uh,
because I think it makes a difference on really high voltage DC
yeah,
stuff when they're
you do.
powering up
I mean,
and
you do get a little like when it's funny when you're testing cables. If there's you got three phases and only one's energized, you will see a voltage on the other two phases. So you do get that induction. But not that I know. A lot of them are still copper, actually. A lot of the underground stuff. So that's
right. Oh, because
a
weight's not an
little
issue
bit
anymore.
better,
So I guess
yeah.
there's. Well,
But
I
there's a lot
wonder
of
would it be
aluminium
cheaper,
connected too.
copper or aluminium?
Aluminium's a lot cheaper, from what I
It's
understand.
cheaper. Okay,
Yeah,
right. Yeah, but that
because obviously
changes with the
cost is a big
commodities
part
market.
too.
Yep. Oh,
Yeah,
of course. Yeah.
cost in electricity's become a bit of a thing lately, and as you know, like the renewables are just going crazy at the moment. So
Oh,
we're
yeah,
probably going
yeah.
to
It's
see a lot of
nuts.
things
Is that
happening in that space.
right? You got any personal thoughts on that? Whether or not that's a good thing, bad thing,
I
troublesome?
think it's good. I don't know about you, but I've
Yeah.
had solar for a few years
Yeah.
now,
Same
and
here. I've had
you
it
know,
forever. Yeah.
I'd like an electric vehicle if I could.
Yep.
Um,
Got one. They're great.
yeah,
Yeah. But they're
I
not for
mean,
everyone, of course.
no, community batteries are sort of virtual power plants. I like the idea of, say, like at the moment, you sell your power to the grid. it'd be kind of nice if they were to bank that power somehow and give you the chance to buy it back in a battery.
Yeah, I mean, I know that I'm generating excess solar into the grid. I know that my neighbors are using it. Why can't we have like a little neighborhood monitoring thing that like, oh, I know it's being used by my neighbor. Oh, I can just charge my neighbor. And like you can literally buy it off your neighbor.
Yeah, they have community batteries around the place too, and they actually or virtual power plants I think they call them, but they also increase resilience a lot too. Um, we've got some places down the coast that were badly affected by bushfires, and they can get isolated for quite a while because I think the thing about Australia, it's such a large country. We've got these transmission lines running everywhere, and the power does come from a long way from where it's consumed. And so, it's got to pass through, rural areas, and they're often subject to a lot of, disruption from storm and floods and fires and stuff. Yeah, and it can impact the communities a lot. So having a little local storage is probably a good idea. I mean, I like the idea of a bit of renewables scattered around. Isn't that what we're working for anyway? I mean, working towards a better sort of,
Oh yeah, no,
you know,
totally. We want, to get it. Yeah, I would like I mean, what? I think Australia has the highest solar uptake in the world, right? Like
yeah, it's
35, even
huge.
40% of homes have solar
Yeah,
now.
well,
It's
yeah,
massive.
we've got supposedly we've got over 200,000 customers that have some sort of renewable energy system at home
That is just in
out of a million,
our
out
state,
of
right?
just in the company I work for.
Oh,
But
just the
so
company in
yeah,
just in
so
this state.
and
Yeah,
we're
yeah, that's
yeah, so we're
wow.
just sort of Western Sydney, sort of we go sort of north of Candos up there to Bylong and Katoomba and South to Ulladulla and into Parramatta and big area.
That's just yeah, that's a huge number of people. Now, if you're a linesman, you're working on a line. How much of a fear do you have of somebody's installed a non-compliant solar thing? You've gone in there, you've actually
We
locked out the grid with your
yeah,
padlocks and everything,
we
and then some
actually don't.
bastards.
I tell you, Dave, if I was fearful, I'd be worried we're doing something wrong. We are very good at protecting ourselves and the workers, my mates. Um, we always isolate. We test the isolation. We lock it and test it. We danger tag it, and then we bond it. So we generally, with the high
Okay,
voltage
so
network,
you would strap it. You would have an
yeah, we
earth
run
strap or something, right?
highly rated bonds between the phases and then down to earth. And when it comes to the solar installations, we don't necessarily go through and isolate them all, from what I remember. But like I said, I just have to preface this: I have been out of the field for a couple of years now, just a couple, but I keep my eye on everything. And yeah, they use bonds on the LV network now as well, and they just because all our they're what, islanding, is that what they call it? When the
Yes, yes.
yeah,
Every solar inverter in this country that's sold in this country must have auto islanding, which
yeah,
means that if the grid fails, you can't. It will shut down. It'll shut off
that's
its
right.
output
Yeah,
and it
if
won't
it doesn't
export.
see
Yep,
that,
yep. If it doesn't see the grid, it won't generate any power. That's why if power to my home fails, I don't care how big my
yeah,
solar system is, it's just going to shut
can't
off.
use it. Yeah,
Right, you can't use it. So you've got to have like a local battery, you've got to have an AC battery solution, or you've got to have a local islanding battery solution at your home. So yeah, it's got to shut
yeah.
off.
So we don't worry too much when we're working on the network because it really is safe and it's really isolated well. And we have a lot of paperwork too. So after you complete the isolation, you all sign on. Everyone in the party signs on to an access authority, which you know it details where the isolations are carried out. So every member of the team knows where the isolation is. So they make sure they're working inside it. And there's a set of visible earths hanging as well, set of
Well, I
yellow
was going to
visible
ask that.
earths.
Where is the earthing point? Like if you want to
So they
isolate
just hang
the
them on the
power pole
wires.
above.
Yeah, they hang them on the wires. You go up with your EWP, you test it, and then you hang your earths on those wires. And then they come down to the ground and you drive a stake in or use the earth on the.
Oh, okay. So you'd physically drive in a stake, right?
Yep. Or if there's an earthing point that's suitable on the pole or. But the work party can see those earths that are at the fringes of their work site, they can physically see that they're on there. So they know not only have they signed on, seen the isolations take place, seen the testing, but then they can see those earths and know that they're inside that isolation where it's safe.
Right. So, but how, if you're driving a spike in, how would you know that's an adequate ground? Because that has to do with the soil moisture
It's
and the
more,
whole.
it's more the short circuit protection. So the earth has three connections on it that run between the phases of the HV. So the three HV phases are bonded together.
Oh, got it. Okay. Right.
And then you have an
Right.
extra
So
lead that
it's a.
runs down to the ground as well,
Oh,
just to
okay.
keep
So really, you're
any
doing
induction
short
and
circuit
other
protection rather
short. You're
than earth
shorting it. Yep.
leakage protection.
Yep.
Got it.
Yep.
Okay. Yep. Sounds
And
good.
our isolation systems. It's funny. I'll tell a bit of a story. I came from Telstra, or it was Telecom back then,
Yeah.
and it was very digital. I came here and I said, oh, as an apprentice, I was like, what are we going to do? How are we going to turn the power off? What app have you got? What are you going to do? They're like, oh, we got this
Noob.
stick. Yeah, noob.
Yeah, we
We
got
got
this
this
stick.
stick. And I said, what do you mean? You're joking. No, we got a stick, and it's literally an extendable stick that's
Yep.
tested. It's insulated and tested regularly. Um, and
So
you
it
reach
isn't
up
just
and there's
a broom
blades.
handle.
No,
Isn't just
and
a
they
broom
have,
handle. No.
under our safety rules, you must look at the date on it when it was last tested, and it
Oh,
must be in
right.
date. We're very good like that. It's really good, and it works really well. And yeah, they just pull the blades. They're like a knife blade, and they just pull the three blades, and they hang
Okay, so
down
you
so
would
you can
insert
see
this
them.
long. So you would insert this long pole into
That's
like
right, with a
a
hook on
little
it.
tube on there, and then physically pull it.
It's got a little ring. You put your hook and you pull the ring down, and the blades come out, and it de-energizes. And
Right.
yeah, you've got that
Nice.
open point now. And
Yep.
then the other type, of course, they're called US cells or underslung links, and then we've got our ABSs, which are our air brake switches, and they're the ones with the handles. You unlock those, and you can open the air, and they're usually what a an open point, what we call an open point, because if you don't know, the way the feeders work is it leaves one distribution breaker at the zone sub. It goes out on the poles and wires along the top. The top set of wires is the HV, and it goes out, and along the way it gets fed into pole mounted transformers, which then produce the LV. But it'll get to a point where it's sort of halfway out through the neighborhood, and then it'll come back again and go to another breaker. And in between, further out in the network, there's that air brake switch in between those two feeders. So the two feeders have an open point where they can be joined if they need to, or it's permanently open.
Okay.
And that's called
Right.
called a ring feed.
Oh yes, yeah, exactly.
You know what I mean? It goes
Houses can actually be wired. Well, I don't know if they can be
the
wired like that in New
UK,
South
the
Wales.
UK do it.
In the UK, is it that
Yeah,
does
to
a ring?
save on conductor. Yeah,
We use a
yeah,
radial
that's right.
system which goes out from the one
Yeah.
point, but you can actually have a ring.
Yeah, not all of our distribution networks like that, but there's still lots of radial feeders. But what's cool about that is you can close that open point, which will bond both of those feeders together, and then you move somewhere else and you open another point, and so you've moved that open point now, and then you go back to where you were before, and now you can open up that other one, and now you've got an isolated section in between. Does that
Right.
sort of make
Ah,
sense?
nice. Yeah, yeah,
Got
totally. I
a
can actually
circle with
visualize
two
that.
two
Yep.
isolated points in it. Yeah. And so initially for the day of switching, you'll get there, you'll call control, get on the switching plan, everyone's ready to go. You'll close that open point and bond the two feeders together. Then you'll move down the road somewhere and open up another open point. And then from that open point, that'll probably be one of your isolations, one side of your work site. Then you'll move back, through your work site to where you need to go, and then open up the next one, and now you've got your isolations, your two isolations. But then either side of that still powered up and still back to the two breakers at the zone
Yeah,
sub.
because you want to minimize the number of people that are without power,
Yeah,
right? So you
disrupted.
want to
That's
try and
right.
choose
Yeah,
the optimum area to
yeah.
shut down. So how do you do that from like a mapping point of view? Do you
Oh, we've
guys
got a
have
lot of
massive
systems. Yeah,
drawings that like, or is there some
oh, it's
app that
digital
you can,
now.
right?
It's digital
Yeah.
now. And yeah, it's all well mapped. I mean, there's everything you want. There's all the paper maps, but there's also all the digital mapping as well.
Right.
And
And
when
so
the
can
switch.
so does the app, like, if can the app, is it smart? Can it tell you, like, okay, we've got a fault here. Okay, go over to this pole over here and break that and break this one over here, and that
Well,
minimizes
as a
the area
switch,
that's out,
as a
or
switcher, it's up to you to understand the network and what the switching plans for like what we call like a programmed interruption or an outage that we know we're going to have. Those switching steps are written down and they're passed through a chain of responsibility, and two or three people will look at them before it gets to the control room. And so they'll make sure that the switching steps are correct. You do a close open here, you do an open at this air brake, you pull some underslungs here, you test an earth. The poles you're working on are the poles inside this isolation and so on. So that's all done fairly well. But as for faults in the field, well, that's sort
you
of,
have to, yeah,
you
you have
do a
to use
line
your best
patrol.
judgment.
You might
Yep.
drive along and see what the cause is. It might have been called in. The customers are very good at calling stuff in. The breakers themselves, some of the relays, they actually can look down the line, and I think they use what's called a Moe diagram. It's it's an expectation of the resistance, the impedance of the feeder for a given length and load,
Right. So
and
they can
when a fault
impedance
occurs.
test the line somehow, sort of
Yeah,
like transmission line impedance test, pulse test or something.
yeah, like a echo, what's it called? Time domain reflectometry, but mostly it's the fault data coming out of the relay will sometimes give you a distance. So the distance has been calculated for that feeder under normal conditions, and so a given fault at anywhere along that feeder will produce a certain current. And when that current does come from a fault, you can now say, oh, it must be this distance away. It's probably a face-to-face fault at this distance. And then, the control room can give you a rough idea. You can look at your map and say, oh, that's on such and such a road. Let's head out there and have a look.
Very interesting. Like, how do you do load shedding and stuff like that?
There's some automated load shedding to prevent a transfer. Like if you knew that the load from the network was going to rise so much that it would eventually, the transformer would trip from overcurrent, you'd obviously want to de-energize some of those loads so you didn't get to that point, because there's no point knocking everyone off when you just want
Yeah,
to,
yeah, right.
so they do have some sort of anti-cascade, I guess you'd call it. They do have some load shedding, and it's, they prioritize the feeders essentially. So, the hospitals and so on are on for the longest.
They would get the priority.
Yeah.
And I've there is apparently some new smart solar inverters that you guys can control. You guys
Yeah, I've
can
heard that.
switch them off
The retail
remotely. I've heard
section
that.
was taken away. We don't do the retail anymore. And so a lot of the metering and that sort of stuff is sort of independent now. And they're the ones coming up with the ideas of, the different load balancing and the pay per time a day use models and all this sort of stuff. And yeah,
And there's rumors around that you can adjust the frequency and or the voltage on the line to then will automatically disconnect the solar inverters, because all
ooh,
solar inverters are programmed if they meet the not only the Australian standard but individual state standards, I believe, for voltage and frequency limits. And if the grid's
yeah,
outside
they
that
do.
voltage limit, they'll shut off. And you guys can sort of tweak it. That's the
They
rumor that's
they
going
can't
around. But
per se tweak the voltage. The transformers. It's funny. The transformers. When I first started working, I thought there should have been more electronics in the transformers. There should be
right,
more
no, there's none. Is
smarts.
there? Right,
There's
there's none.
none. And you know what? After seeing a lot of them get hit, yeah, a lot of them get hit by lightning and or storms and that. I understand because they can just send them back to the factory, drain them out, clean the coils up, and they're back in service. Um,
Right.
Oil
Is
and steel and
how
equipment.
often do you get a transformer fire?
Not
Is that
very
common
often.
or
No,
no?
not very often.
Right, they're
It's
fairly
actually,
robust.
yeah, it is. It's all, and that's why the times that we have tried to use smarts that they might have. So they have a maximum demand indicator on them, a lot of these transformers, and we read it once a year, and it just shows the maximum amperage that the transformer got to, and
Oh,
that's how
got
we
it. So it's
predict a
just
bit
a
of our
peak
demand.
indicator. Okay,
Yeah, it's a
right.
peak indicator, and we just write it down once or
Ah,
twice a year. But we've tried to
ah.
make versions that are electronic and report back via modem. And of course, sometimes they just can't handle being in the Aussie sun,
Yeah,
getting picked
yeah.
on by
You'd get more
cockatoos and
failures
lightning
in the
strikes and that. Yeah,
smart electronics than you
yeah,
would in your
it's true.
dumbass transformers.
Yeah.
That's right.
But our zone subs have gotten more modern. We've gone to Ethernet now for a lot
Oh,
of them,
right. Okay.
Ethernet connected
Yep.
relays. And we've also gone to SF6 gas. So that's the other thing. Breakers are incredibly, because of the high voltage, an arc can be, 5,000, 10,000 degrees. The surface of the sun's only
Oh, yeah.
5,000,
Surface of the sun temperature. Yeah, it'll melt
Yeah, and
everything.
so it melts everything, burns the contacts, so we don't want arcing in general. But when the breaker opens, there's going to be some arcing because it's pulling two contacts that are energized apart. So there's a number of ways to prevent that. You can blow the arc out with compressed air. That's sort of an old method, but that's quite loud, and the compressors have to
Right.
run for a bit, so they can't fire multiple times. They have to wait 10 minutes while the compressor fills back up. There's the oil-filled breakers, and the oil will quench the arc. Then you've got arc chutes. They're like interleaves or sort of steel sheets with a little bit of a gap between them, and the
Ah,
arc
yeah.
magnetizes those sheets, which then draws the arc in.
Ah,
Arc
interesting.
shoots, they're
Okay.
called, yeah. And
Ah.
then the latest ones are SF6, sulfur hexafluoride, and that gas does not like to conduct at all. And so you can put it under high pressure, and you can make the bus bars. What in the past might have been the bus bars might have been 2 meters apart. Now you can put them, 100 mil apart. At
Right.
132.
But if they blow, then you got to go in and recharge that SF6
Yeah,
gas,
that's
do
right. But
you?
they have,
Right.
of course, they've got pressure sensors in them. They're watching everything,
Right.
but they're also extremely low maintenance as well compared to the older
Okay.
ones. Yeah.
Right. What is the speaking of maintenance? What is the most maintained thing on the power lines? What like the
The
suburban,
poles. The
poles,
poles.
poles,
Yeah,
right?
we once every 3 or 4 or 5 years, each pole gets looked at and drilled and tapped and hit with a hammer and checked over. And
Oh, okay. So the physical structure of the pole, the
yeah, of the
physical
poles and the cross
tree, the
arms.
actual right, the actual dead tree that
Yep.
it's all
And
it's all
yeah,
hanging
that's
on.
all hanging on.
Right.
Yep. And now
I
and then
guess that's a
insulators
plus
will crack.
point. Right, and the ceramic insulators will crack,
Yep.
right? Is that just a
A little bit.
manufacturing thing? Heat,
Oh, just the age of
UV?
them too. We've moved away
Yeah.
from ceramics now to
Oh,
polymeric. They're it's kind of like
polymeric.
a silicon. Some of them they're
Oh,
all sort of different,
interesting.
but
Okay.
because wires can or conductors they can either terminate at the pole or pass overhead. If they pass overhead, they're on pins, but if they terminate on the pole, that's when they'll hang off the polymerics or the thimble insulators as we call them. Pair of dead ends. The dead ends they're like a spirally wound piece of metal that grips the conductor and then bonds over the top. But there's a lot of different gear out there that you'll see, but they're moving towards, as you know, because you can't just trial things,
No, no.
wholesale. You don't want
Yeah, yeah.
problems, once
No,
you roll
exactly.
stuff out, you want it to last. Because most of this equipment, once it's installed, it's in there for 10, 15, 20, 30 years,
Right.
you
Yep.
know?
It's crazy.
Yeah.
Where would the cost? I mean, this is probably company confidential, but where is the biggest cost base? Is it generation? Is
For,
it transmission? Is it
so
maintenance? Is
I
it
guess
personnel? Is it?
we probably don't pay for generation because the electrical energy is sold by the retail side. So they're charging their customers and they're buying the electricity off the generator to do that, I guess. So for us, it's going to be, I'm not sure. There's a fair bit in the vegetation maintenance space,
Okay. Yep.
keeping trees clear of wires.
Trees, lopping trees and stuff
Yep.
like. Do you guys just call in any tree lopper, or do you guys have your own
No, we have.
specialized tree loppers?
Yeah, we have. We usually set up some contracts with them, and we have a couple of different major companies that look after us and trim the network. Customers. There are certain times that customers just can't really work on trees near the network, obviously, because it's just highly unsafe. And so, there's certain work there that we have to do, for the customers, for the councils, and so on. So, yeah, we have an envelope. It's a set of clearances that the trees need to stay outside of. And so they trim them back with a little bit of a regrowth factor, and then trim them, annually, semi-annually, every couple of years, depending on the area. But yeah, cross arms. They used to be timber. Now we're getting ones that we've trialed metal ones. We've trialed
Metal
composite
cross
ones.
arms.
Yeah, we've trialed every kind of thing. There's metal poles, concrete poles, timber poles,
Yep.
composite poles, and they all have their sort of benefits and
Right.
disadvantages.
Power factor correction. Is
Yeah.
there much?
So,
How much of that is on the network? Like how many
well,
and what types and
from
where
our
and
point of view, we don't have a lot of it. We sort of do. If you have a load over a certain amount, it's up to you to make sure that you have power factor correction in the building.
right. So
So
if you're a giant factory with massive motors going, you
lights,
have to install.
you
You
need some.
legally you have to install your own.
Well, you'll get charged more from the
Oh, you get
retailer
charged a lot more. Okay. Yeah.
based on your power factor. So, for us home punters, we don't get charged power factor,
No. That's right.
and it's not even monitored in the meter in general. The
Yep.
electronic ones probably can, but
The
we
newer
don't pay
smart
for it.
ones do, I think, but
Okay,
but we still don't pay for it. Yeah.
but the bigger guys do, and so they'll have a power factor correction cubicle, which I think it's just a cap bank that switches in and out. Where they sometimes have it in an infrastructure sense, like inside a zone sub, is there might be a high voltage customer that'll have a feeder that goes to, say, an aluminium smelter or a
Right.
glass
Yes. Of course.
smelter.
Massive power demands. Yeah.
They dip these electrodes, 11 kV electrodes, directly into the bauxite, and
Yeah.
just the power that it draws in a split second from the system
Yeah.
is crazy. So they have to design, I think they call it a reactor. It's basically a big coil choke, I think, that
I
kind of
was going to
smooths the
ask, yeah,
power.
because most power factor correction would be capacitive, right? I was
Yep.
going to talk about are there any inductive power correction?
Yeah,
That
look,
that,
I'm
that
not
would be a
sure,
case
but
where they use it, right?
yeah, yeah, it would be by exception, for special projects. But I think, the average, home device these days, it's pretty good. Like, as an electrician, I remember working as an apprentice, and definitely if be pulling a fluorescent light apart to fix it for the customer, and the capacitor's blown, and it's just in parallel or whatever, you just pull it out. The power factor correction, away you go. But you don't do that in an office. You don't buy the non-power factor corrected lights when you've got 1,000 of them to put up in
Yeah, exactly. Yep.
or you'll be paying for it.
Yeah. So the big question everyone wants to know, of course, is what meter do you guys use? If you're a linesman, if you're out there, you're out in the
Oh,
field, which
oh,
meter
that's
is
a
there?
good
Are there
question. So we
approved
used to
meters?
use, yeah, oh, absolutely. We used to use the T140. It was a fluke, and it's a style with a probe at one end. So it's not like your traditional rotary dial type or anything like that, or push button. It's a single. Well, they used to use test lamps, Dave. It was
Oh
just a
yeah,
pair
yeah,
of a
good old
pair of
yeah, lights.
lamps,
Yeah, no
But
worries. Yeah.
obviously, with all our testing, we're pretty smart around it. We test before and after, so you make sure your meter's working correctly. All right, so it's actually reading. Then you do your test and you prove your isolation. Then you test your meter again. So even with a set of test lamps, theoretically, you shouldn't have a problem. But if you fail to test again, and you've got a blown bulb in your test lamps, then it wasn't going to pick up your test
It,
properly, was it?
exactly.
So
Exactly.
we moved away from that, but it's a similar thing. It has the two probes, because you've got to imagine the guy might be on a platform or hanging off a ladder in his belt, and he's reaching above his head, and he's going from phase to phase, and this is only LV, and so it's a fluke T140.
I've got it open right here. And for those curious, it's a Cat 4, only 600 volts. Cat 4, 600 volts. Cat 3, 690 volts. So it's not as good as it gets. You can actually get Cat 4, 1,000 volts
Yeah,
these days, but it's the form factor. It's
I
the
think
form factor. It's
it's
the
the form
proby.
factor. We have.
Yeah.
I'm going to get in trouble because the guys are going to roast me. I'm sure we've moved
Yeah,
away from that
absolutely.
one now. We've moved again.
Okay.
But I know, for example, in the zone subs, they use a higher cat rated one again,
Right.
because
Would
you
you know
do
the
have the
specific model?
potentials there for, 11 kV. I wouldn't
Oh,
know, but
yeah,
I
of
can get
course.
back to you. And
Yeah, get back to me, please. I'll put it in the comments.
when we
Yeah.
do the high voltage, there's special
Yeah.
gear there. We have what's called a Modi Walk or Modi Walk. It's the brand, and it comes with a little hand tester, and it's a
How do you
feel.
pronounce that? Modi.
Modiwark, maybe Modiwark. I think it could be the
Moduark
brand.
kit. Okay. Yeah.
So that but there's a lot of
Oh, I
brands,
see it.
and
Yeah.
some of
Right.
them are non-contact testers because with high voltage ABC bundled aerial bundle conductor, it's insulated with XLPE. You can't pierce it with your tester, so you need to just check on the outside of the cable with a field tester. A lot like those voltage pens, which by the way we do not use those voltage pens.
No, well, this is basically a high voltage
Voltage
professional
pen,
version of
yeah,
those voltage
it
pens,
is,
right?
yeah.
So it is a non-contact tester.
Yep, and you'll push that up on the pole because obviously you can't get close enough on the stick. Sorry, because obviously you're not going to be within clearances or work on high voltage while it's energized.
Right.
So you test from the ground generally, or in a bucket or EWP. Sorry, you might test from in there nearby. Sort of push it near the mains. You'll test each of the phases, and then you'll test the meter itself. It comes with a little handheld thing that you push a button and it creates a field, and you hold it on there, and it
Ah,
beeps.
interesting. Yeah, specialized bit of kit. Yeah, of
It
course.
is. We've got a few
Makes
of those. We've
sense.
got clamp tong ammeters as well that can do
Yep.
1200 amps at 132 kV.
Yeah, right. Yeah, yeah.
Push them up
But
there.
I
So
assume you wouldn't. Would you use a current clamp that often, or is that
not really. Well, in the
not
zone
really?
subs, when
No.
you're doing, they're called protection technicians. I know you get a lot of people listening. So if there's any young budding engineers out there, have a look at um, you know employment in this field because it can be really fascinating. But we do a lot of current measurement in the zone subs because all of the protection equipment, the breakers and everything, that's what they use to trip. They even have what we call differential protection schemes, which is where you ship a portion of the current you're sending on an overhead pilot wire to the far end. And
Oh, really?
that current holds a relay
Ah.
open. And the moment that current
Oh.
stops, that relay drops. So it's like, I've
Wow.
sent you this. If you don't receive it, you need to trip.
Yeah.
Yeah, and that
Wow.
was
That's
very old
interesting.
school, and that's really just a set of CTs
Yeah.
that then send that current over a pilot wire to
Right.
the far end relay. Yeah,
Nowadays it'd be done with comms, right? It'd be
it
a
is,
comms
and
thing.
it's optic
Yeah.
fiber
Right.
now. Yep,
Right. Yeah.
multi-strand optic
Newfangled
fiber.
stuff. Yeah.
Yeah,
Yeah. Boo. Boo
we've
hiss.
used radio a little bit. Look, nothing beats the physicality. All the breakers and that, they're all physically
Yeah.
wired. Every single one of them, just about. They were actually a bit shy when they put their first sort of Ethernet style ones in.
Yeah. I bet.
They're a bit
Yeah.
nervous about this because
Yeah.
it's a bit newfangled for us.
Yeah. Exactly. Oh God.
Reliability is important, but protection is, paramount. Safety is overall. Do you know the rule? Is it IZIBIN? IZ's
Oh
got to
no.
be
What's
greater
that?
than IB's got to be greater than I. It's in the AS3000, which is our electrical safe. That's the electrical rules in Australia for an
Oh,
electrician.
okay. Yep.
IZ
Yes.
is the impedance of the cable.
Yep.
IB is the a breaker current,
Right.
and IN is your expected normal load. I think this
Oh,
is
there you
right.
go.
So
Yeah.
the cable's got to have the highest current carrying capacity, and then the
Yes.
breaker, and then the load. So the
Yes.
the breaker should trip before the cable burns.
Correct. That's the whole point.
That's the whole. It says in the front. It's the first paragraph, I think.
Right, is it? I see. This is something that I don't generally know, but I do know that the circuit breaker in your house is not designed to protect your products that you plug in. It's designed
Correct.
to protect the
Stop the
wiring from
cable
catching on
burning. Yeah.
fire.
You got a
Yes.
20 amp cable. You can't put anything bigger than an 18 or 19
Yeah.
or 20 amp breaker.
Yep.
IN could be higher. You can draw 40 amps, but you're just going to trip your breaker all the time, and it's going to be a nuisance.
Exactly.
But
Yep.
yeah, IZ's got to be bigger than
Yeah.
IB.
I've never heard it explained like that before, but yes, that
I
makes
think
sense.
it's
Yeah.
in it when you train as an electrician. I think it's in that AS3000, the Australian standard, and that's our wiring standards for domestic dwellings. There's another one that people might enjoy looking up, and that is the service rules. And the
Ah, okay.
service rules, the New South Wales service rules, they're the ones that sort of it's in between your house and the street.
Okay. Got
What
it.
cable you should run from your board out to the street. What
Okay.
size
Next level
conduit,
up.
how
Yep.
high your service mains need to be above a driveway, how high above an awning, what
Got
size
it.
conductor.
Got
That's
it.
the New South
Yep.
Wales service and installation rules.
Oh, there you
SIR,
go.
yeah. It's another document that's sort
Fun
of,
bedtime reading. Yeah.
yeah.
Oh, this is great. Oh, well, thank you very much, Toby. Our
You're
amp
welcome,
hour is
Dave.
unfortunately up. We could
Yep.
talk about this interesting stuff all day, but that flew by. That is great stuff, which
All
we,
right.
we just don't, because we have no idea about this. Just as a general, engineering nerd, we just take it for
Yeah,
granted
we
that all
use the
this stuff
power that
just
comes in
happens.
to the
Yeah,
house, and that's it. We know
yeah,
there's generators out there. We know there's zone subs, but there
yep.
is quite a bit of engineering that goes into it. There really is.
Yeah, fantastic. I'd love to get like a tour of
Oh,
one day,
let me
like
see
that'd
what I
be.
can. Yeah, I'm not sure.
Yeah.
That's probably something we've never really done, but I know there's some great zone subs that you'd really be fascinated by. And there's a lot of associated systems too that we didn't even talk about, like
Oh,
the
sure.
frequency
Yeah.
injection for the hot water systems,
Oh,
and
yes, of
the
course.
street
Yeah, yeah.
lighting
Old school stuff.
systems,
Yeah,
and
yeah.
there's a lot of stuff in those zone subs that you don't even see, and it's more electronics focused too. So
Yes, which is basically comms over power line. For those that don't know, they send like the hot water thing was a 1 or 2 kilohertz signal, which
yeah, that's right. Yeah,
which was
if
actually modulated over the power line. Yeah.
sometimes you'll hear it. If you've got a fan running, you'll
Yes.
sometimes hear it in the
Yeah.
motor windings.
Yep. Or you'll
Yeah, it's
see it
real
on your
cool.
oscilloscope. I see it pop up in
Ah,
the lab
yes,
all
of
the
course.
bloody time. I'm
Yeah,
taking some sort of mains measurement, and there's my 50 hertz waveform, and up pops this little modulated bloody sine
yeah,
wave on
up
top
to
of it.
7 volts or something
Yeah,
sometimes too.
yeah. It
Yeah.
just sticks out
You
like a
should see
dog's
the
hind leg.
injection. Yeah, at the other end there's a big cabinet that controls it, but then to inject it there's these toroidal transformers and all this crazy gear, and it just looks incredible just to
Yeah.
inject it on, because you've got to inject it onto the 11 kV.
And it's a very low impedance line you're injecting
Yeah.
onto as well. It's like, yeah, it's got to be grunty to. Yeah.
Yeah. So
Wow. Fascinating stuff. All right. Well, thank you very much, Toby.
you're
Awesome.
welcome, Dave.
Where can people catch you?
Oh,
Where can
look,
people
just
follow you? Are you
if
madly
they
online? You do the
Oh, I
Twitters?
do have a website and a bit of a YouTube channel, but if you want to chat power lines or ask any further questions, that post I put up on your
The
blog,
forum, yes. You
yeah,
put an
on the
awesome
forum.
post up on the EV blog forum. I'll link it in. That's where you offered to.
Yeah,
There's
if
a whole
just
bunch of
people got
detail in
questions
there, and
about how
offered
it
if people
works,
have
and
questions. Yep.
yeah, sure.
Yeah, we'll definitely link that one in. Awesome. Thanks, Toby.
All right,
We'll have to
you're
catch up
welcome.
again
Thanks,
in
Dave.
person soon. So,
Yep,
yep.
great.
Cool. Thanks, mate.
All
Catch
right,
you next
cheers,
time.
mate. Bye.